Let us now continue with another example that falls under the ambiguous case. How many solutions are there if side A equals 19, side B equals 10, and angle A equals 120 degrees? Now to restate, how many triangles can be formed if A equals 19, B equals 10, and A equals 120 degrees? So here we are given two sides and an angle opposite one of the sides. So side A is equal to 19, side B is equal to 10, and angle A is equal to 120 degrees. Now let's try to analyze the given. So from the given, we can see that angle A is an obtuse angle since it's greater than 90 degrees. Side A is greater than angle B, side A is greater than B, side B, because 19 is greater than 10. Now, looking at the SSA possibilities table, which is on page 16 of your learning package 1, we can say that the problem has exactly one solution. In other words, one triangle can be formed. Now let us verify the answer by showing a solution. So solving for angle B, since sides A and B as well as angle A are known, then we can use the formula sine B over B equals sine A over A. Note that we can use this proportion because the only unknown in this proportion or formula is angle B. All the rest are given. We have the values for side A, side B, as well as angle A. So by substitution, we will have sine B over 10 is equal to sine of 120 degrees over 19. By cross multiplication, we'll get 19 sine B is equal to 10 sine 120 degrees. And then dividing both sides by 19 will give us sine B equals 10 sine 120 degrees over 19. So therefore, sine B is equal to 0.4558, correct to 4 decimal places. Now note that here, sine B, which is 0.4558, which is less than 1, is well within the range of permitted values for the sine of an angle. Remember that the value for the sine of an angle must only be from 0 to 1. So next. So sine B again is equal to 0.4558. Now since we're solving for the angle, then we will have to use the inverse trigonometric function. So therefore, angle B will be equal to sine inverse 0.4558, which is 27 degrees, 6 minutes, and 59 seconds, or angle B is equal to 27 degrees, 7 minutes, rounded to the nearest minute. So now we have the values for side A, side B, angle A, as well as angle B. Now let's try to solve for the supplement of angle B. Let's call it B prime, denoted by this symbol here, by this notation here. Now note that the sine of an angle and its supplement are equal. Therefore, angle B plus angle B prime is equal to 180 degrees. So B prime is just equal to 180 degrees minus angle B. So B prime equals 180 degrees minus 27 degrees 7 minutes. And this will give us a value of 152 degrees 53 minutes. Now, this notion that the sine of an angle and its supplement are equal can be seen on activity 1.3, Are You Me, which is on page 7 of LP1. So now we have sides A and B, angle A, angle B, and angle B prime. So let's now solve for angle C. Okay, so therefore, adding up all the three angles, angles A, B, and C, we will have the sum, which is 180 degrees. So therefore, solving for angle C, that will be 180 degrees minus A minus B. So by substitution, you get this. So therefore, angle C is equal to 32 degrees 53 minutes. So now we have the values for side A, side B, angle A, angle B, angle B prime, and angle C. Let us now solve for side C, since we don't have the value for side C yet. And remember, when we say solve a triangle, that means we will find the values of all its parts, meaning the measures of all its angles and its sides. So let's solve for side C this time. Now, since side A and angle A are given and angle C is already known, therefore we can use the proportion or this formula, sine C over C equals sine A over A. Take note that when you decide as to which proportion or formula to use under the sine law, make sure that in your proportion, there should only be one unknown. Now, in this proportion or formula, angle C is given, so check. Okay. Angle A is given, so this is check. Side A is also given, so check. Here, the only unknown value is the value of side C. So therefore, indeed, we can use this formula. So again, we use this formula or proportion since side A, angle A, and angle C are known. So by substitution, we get this. Sine of 32 degrees 53 minutes over C is equal to sine of 120 degrees over 19. So by cross multiplication, we will get C sine 120 degrees is equal to 19 sine 32 degrees 53 minutes. Dividing both sides by sine 120 degrees, we will have C equals 19 sine 32 degrees 53 minutes over sine 120 degrees, which will give us C equals 11.9115139, or C is approximately 11.91, correct to 2 decimal places. So note that we now have the values for angle A, for side A, side B, angle A, angle B prime, angle C, and side C. So now, let's try to solve for the supplement of angle C. And let's call it angle C prime. So, angle A plus angle B prime plus angle C prime is equal to 180 degrees. Remember, the angle sum of a triangle is equal to 180 degrees. Now, these three angles, angle A, B prime, and C prime, are the angles of the second triangle that we are solving, if that second triangle exists. Alright? So, by substitution, we will have C prime equals 180 degrees minus angle A minus angle B prime. So, by substitution, we get these values. So, C prime will be equal to negative 92 degrees, 53 minutes. Now, this value for this angle C prime will be rejected. Okay, why? Angle C prime is rejected because there is no negative angle measure in any angle of a triangle. Okay, so an angle cannot be negative. So therefore, for our conclusion, there is exactly one solution for this problem. In other words, only one triangle can be formed. Okay? So, we were able to solve for that one triangle here. And that triangle which we were able to solve is that triangle having side A, which is equal to 19, side B equals 10, side C equals 11.91, angle A of 120 degrees, angle B of 27 degrees 7 minutes, and angle C with 32 degrees and 53 minutes. The supposed other triangle with parts angle A, angle B prime, and angle C prime does not have a solution since the value that we got for angle C prime is negative. And we know that there is no negative angle measure.